Previously on The Bald Engineer.
Oh God, wait a minute, what?
Ooh, you're dirty.
Oh no.
James, you're looking at the wrong chip.
Oh my God.
Excuse me. Farts.
And F stands for fun.
Pick.
Yep, fell right for that one.
Tab is correct.
Oh no, 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 no. New work. Oh my God, are you kidding me?
And
Why is it triggering now? That could have gone a little better. Hello there. How's it going? I'm James, you're you, we're here. I am getting one more software thing taken care of and then we're ready to go. So this was a stream I wanted to do a couple of weeks ago, but time didn't let me. I want to make a design with the new RP2350 chips. And it's basically, I want to upgrade the state mode logic analyzer that I was working on, man, I wonder, maybe like a year ago? But yeah, so that's what we're going to work on tonight. How's everybody doing? Hello. Hey, TMK. Good to see you. Hope you're doing well. All right, so that looks like that's ready to go. Yep, okay. So then I gotta get this to be somewhere else because that's kind of in my way. So maybe I can do like this or this, I don't know. It doesn't really matter because I'm not gonna look at that. All right. this and then go like that. Okay, does it work? Ooh, no, no. Oh. I just realized I'm on the wrong monitor. All right, so this one has to be desktop, the other one. And this one's okay, and then that one's okay. Okay. So now I can go to here. There we go. And then we can get out here. And there we go. Okay, how about that? Hey, Alex, good to see you. You're disappointed with the RP23? Somehow I'm not surprised. Yeah. I think it's a fine step up from what they had. I'm concerned that it took them so long to get to where they are now. So that's my bigger concern. But I mean, I think from my perspective, I think the RP2040 was more or less a MVP. They just wanted to figure out, could we make something, would the market be interested in it? And it really feels like the 53 or the 2350 is essentially version 1 of the product. Like the 2040 was version 0.05 or something. So I think if that's how I look at it, is at least, or that's my perspective. So let's create a branch. So this was the board. So if you guys saw the Element 14 video, we did a video on, it ended up turning into how do you design a 2040 board. The idea was I had a 2040 here and then 2 buffers, and then this would basically be a logic analyzer connection. And so the idea was the 2040 would act as a special kind of logic analyzer called a state mode logic analyzer, which means it only stores samples when the target clock transitions. And so like if you almost every single logic analyzer you buy right now, they're timing analyzers, meaning that they run at some high sample rate and then reconstruct a waveform afterward. A state mode analyzer is much more memory efficient because it only stores samples when the clock transitions. Now the 2 problems with this are, 1, you miss all kinds of glitches because you're only looking when the clock transitions, and number 2 is you have to delay the clock so that you can actually line up you're capturing data at a valid point. And so on this board, well, not on this board, but on its companion board, I have a clock timing delay circuit that I haven't gotten to use yet. But the idea is it will actually delay the system clock such that you can change where the capture window is at. Anyway, the whole concept of this was, oh, here we go. This is better. So the whole concept was I had 2 RP2040s so that they could both capture about 16 bits. And then each of these boards had actually one of these boards has a timer on it to generate, or a counter to generate timestamps. And then the other board has the delay circuit for the clock. And then you would actually plug these 2 boards together, and then one of them would be the main and the other would be the secondary. With the 5340 or 2350, I think I can get rid of almost all of that and just use one chip, one microcontroller. So that's more or less what I want to try to do tonight, is figure out if there's enough signals there to do what I want. So that's what we're going to give a try. So, how do I want to do this then? Because yeah, I think I am going to actually, let's do this. Let's create a new folder for RP2350 and then a new folder, and I'm just going to hope that Git figures this out. RP2040, because then I'm going to take all of those and just do that. except for git ignore. That can stay. Oh, wait a minute. What did I just do? Oh, I think I actually copied git too, didn't I? No. Okay. All right. Let me see what that's going to us. We want to ignore everything there. Ignore everything below there. We want to ignore that file. And then the rest of this is probably fine. Okay. Stage that, moving stuff around. Hey, CKY. How are you doing? Man, that is a name I have not seen in a very long time. Welcome, Raiders. Glad you could come in. Sound is occasionally scratchy. Could be that. So let's try that. The other thing could be is, let me make sure that's not. So I'll try those two things to change. And if that doesn't improve it, then I'll have to get out the monitor and listen. Yeah, I've been busy as well. It's been a while since I was back on Twitch. What was your stream? What were you streaming today? All right, that is taken care of. Let's come back in. Because now what I want to do is then just grab this. That should be all we need. Copy this, and then I'm going to put state mode logic analyzer RP2350 into the name because that's basically what we're doing. I apologize. I was hoping to get all this done before the stream started, but I decided to eat dinner instead. We're going to get KiCad going here in just a second. And make sure that both of these files load, and then we'll move on. So the last time I worked on this was, okay, October of 23, so almost a year ago. That's crazy. That'd be crazy. Hey, GB, good to see you. Firebot code, nice. I like when bugs get squashed. I dislike when they are problematic. Okay, so this was the old design. Oh my gosh. I totally forgot to change. Oh well. All right, well here's the old design, which actually works out because I was doing a bunch of desktop stuff, so that was totally on purpose. So anyway, you already saw the old design, you were just staring at it. So we're gonna see what this new one looks like after we clean all that up. All right, so that all looks good. Let's come back here. Let's do an initial commit. So like this, we can ignore. And then what's the, I think it's PRL you can ignore. And then we can stage all those, and we'll just do an initial 53 or 2350 commit. Sounds like a soft, oh. Okay. I am using NVIDIA Broadcast. I wonder if it's got the wrong. Let me try that and see if that makes a difference. And if that doesn't, then let me check one other thing. Actually, let me just listen to it myself. So let me say a few things, and then I'm going to unmute one of my streams. Yeah, I don't know that I'm going to be able to fix this. I think I know what the problem is, but it requires a reboot. I'll also try one other change and just see if that fixes it. But then I want to check, make sure that this is using the correct source. Yeah. We'll give that a try. Tell you what, give me, like, if you're still hearing it now, let me know, and then I will restart broadcast. But otherwise, okay. Let me restart broadcast real quick. So let me just do a mute. I'll be. Let's see if that gets picked back up. And then this should still be, let's go back to studio, common. Yeah. Now, if that doesn't work, then I can't do anything else. So we'll see. I've been having a lot of trouble with it lately, like a lot of trouble. So, okay. Let's try and go and see. Oh, I need the other window back. I need this here and this here. But then that covers that like a jerk. Okay, so right off the bat, first thing we're going to do is we're going to just delete. Well, actually, you know what I'm going to do is I'm going to move this over here. The next thing we're going to do is I'm pretty sure I'm going to need a bigger page because reasons. So, well, I think what irritates me with RTX is when it works really, really well. But when it doesn't, there's nothing you can do. Like, and it's not obvious when it's going to stop working. Now, probe inputs, we're probably just going to, I'm going to keep the buffers for the moment, even though the 2350 is actually 5 volt tolerant. I don't want to, I think I want the protection of a buffer. The other thing I've been thinking about is by using LVC buffers, if I change their VCC, I should be able to change their threshold voltage. And so it might actually be worthwhile to have it where I guess you could do that with IOVDD too, couldn't you? I still like the idea of having a protection though. Hey, Christian. Yep. New session of pain and suffering. So this is that clock delay circuit I was talking about. It's a AD something, something, something. It's pretty cool. You basically, wait, is that it or is this it? It's over here. So it's actually this, it's an LTC part. It's pretty cool because you give it an analog voltage and it affects the delay. And so what I was doing was I was going to use a DAC, a DAC to change that voltage so that I can move that delay around. That's why I don't know, I might still try to play with that circuit because I would like to know if that circuit's working before I do my next board, but it's not that critical. Okay, so we made some room. Now let's try and find a good reference for the new chip. And so first thought was, so Solder Party provided a minimal design document. I wonder if I should just use his. Really, all I want at the moment is the symbol, because, yeah, we're going to go look at that. So let me do this real quick. Downloads. I need to launch a second instance. Projects. PiPico 2350. Minimal board 2350B. Oh, what's the difference between the A and the B? I forgot which is which. Like, which one has the built-in memory and which one doesn't. So A, yeah, that's what I'm trying to figure out. Come on, come on, come on. So, or is it just the package is what's different? Well, okay, I want the B because I want the 80. I want all the pins. Hey, TZ, good to see you. Oh, okay, so A and B are the package, and then the last digit is the memory. So number of cores, type of core, RAM, ROM. Okay, okay. Now that makes sense. Okay, so we do want the B. I'm probably not going to use an external flash, but I do want to use. I do want an external RAM, because I want to be able to capture as much memory as we can. Let's come here, and I want the I think I want that. Send it to Port Quake. Nice. Hey Thomas, welcome to the stream. I actually did actually get a 2, and so I think this is the 60 pin package though, so it's not all that useful to what I'm doing now. But I did order. I wanted one to at least have one on hand, and so I've got one. I haven't programmed it yet, so we'll see. Hey, is it Furch? Apologize if I get the name wrong. USB 3 today? Huh. Yeah, actually, somebody on Twitter kind of gave me a... I was complaining that it's only USB 2 or USB 1.1 still, and they're pointing out that there's no microcontroller under $2 that has USB 2, which is a reasonable comment, perspective, we'll say. But I still kind of feel like, I don't know, shouldn't, why not? All right. So I'm going to assume for the moment GPIO 0 and 1 are both SDA, but I am going to just put a note here because I'm not 100% sure. I think what this person was getting at, and I don't understand the way the IP stuff works well enough, but I think their point was it's just too expensive to license it, so that's why it's not in yet. Which, you know, I don't know for sure if that's if that's the case, but you know, I can understand that. All right. Oh my gosh, that's gonna happen a whole bunch of times, or once. But yeah, I'm kind of curious how they. It's like they do all these upgrades and add all this capability, but they didn't want to go for high speed. It's like, come on, why not? Okay. See, this is where I ran into issues last time. So if I move my timestamp, I wish I hadn't just done that. Let's delete these. If I move my timestamps down, so the idea behind a timestamp and a state mode analyzer is because you only take a sample when the target clock transitions, you don't actually have any idea what the time between transitions are because you're not keeping track of anything. And so the idea of a timestamp is you stamp each sample and then you can get some resolution of what the time between samples were. And so, like, for example, it'd be how you could determine what was what's the target clock, since it should be, or you'll be able to recalculate it. So yeah. Hey, Francois. Good to see you. I'd say it's been a while. I think it's been a while on a stream, but that's probably only because I haven't been streaming the last couple of weeks. All right, and then I'm going to grab these and hit Y, and then go X, and I'm pretty sure that's going to work out how I want it. Wow. Did I count that right? 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6. Wow, so much I/O. I could actually, So, I think one of the problems is going to be, really? Must be off grid. So I think one of the problems is the the PIOs are still 32-bit. So yeah, I can clock this all in. No, I can't. I need one of these to be the clock. Darn it. I really want it 32-bit. Hey, Viper. What a housewarming. Yeah, I heard you were moving. I had no idea. So here's what I'm thinking is buff is going to be one PIO, and then the timestamp is going to be another. But in order to do that, I think they both have to see the clock because I can't share that bit between the two. What are you talking? I have no idea what. I don't even know what I just pressed to make Cortana pop up. What a waste of effort. Just do it. If you route the lines now, then they'll be done. Well, I don't want to use an extender or anything like that because I'm trying to, well, I mean, if I did that, I don't need the new chip at all, I guess. I mean, as long as I get 24 signals and then a couple extra, so 24 plus a couple extra, that's enough for an 8-bit, or a 16-bit address bus, but an 8-bit processor. That's sort of what my target's been, is I want a better logic analyzer for stuff like the Apple II. And I have an NES project in mind where I need to be able to watch what's going on the CPU bus. Huh. Here's another thought. I guess I still need GPIOs to do it. I wonder if there is a way to run a counter and have it get loaded into RAM at the same time that a DMA from the PIO happens. Because if I could do that, I wouldn't need an external timestamp. Did I miss something? Did they remove Cortana in Windows 11? I would have zero idea. You can chain state machines, but you're still limited to 32 I/O bits, right? And so I think no matter what, you're for a state machine, that's it. I guess, or yeah, okay. So I guess could yeah, I follow what you guys are saying. The they have 32 IOs and 2 interrupts, could pipe a clock in through one. Oh, that's a good point. Except the one of the interrupts has to be you can only put 32 pins into the GPIO, and that's it, or into the state machine. They can't handle more than 32 signals. So one of those signals can be an interrupt, but that doesn't buy me anything. Now I could be wrong, but that's how I understand it. I don't think you can use more than 32 signals. Or is it just that the FIFOs are 32? I feel like there was something in the in the manual that said the PIO is limited to 32 signals, or GPIOs. So this is the old one too. It's going to take forever to find that. I was hoping they'd have I just want the block diagram. I don't know. I guess I could actually try doing this on a regular board just with a smaller number of signals just to see what I could do. Where is the... Because where I was getting at earlier is... Where is it at? Where is it at? Where is it at? So more PIO blocks, blah, blah, blah. What is this? Input, output, delay, and skew? Really? Yeah, I thought it was like right in here it says, yeah, sure, you get more GPIO, but it doesn't. Wait a minute. Yeah. State machine inputs are mapped to 32 GPIOs, limited to 30 GPIOs for the 2350? Why? Amount of freedom depends on the minimum interface. Yeah, wait, why this? How many cores does it have? It's still a it's 2 cores, but there's 4 cores in the design, and you can switch between RISC and ARM, but only 2 cores can talk to the fabric at once. Yeah, you're always limited to the maximum consecutive pins. Okay, changes. So GPIO's base adds for, oh, wait, adds support for more than 32 GPIO per block. Oh, yeah, so they're just saying that this just adds support for more IOs, but you can only get 32 at a time. But I'm still wondering why this says it's limited to 30 GPIOs for the 2350. I wonder if that's a misprint. That just seems weird to me. That doesn't jive with what I thought. Oh, what page was I on? There's not a back button in this one, is there? Because that's just going to go back a page. Shoot. Okay. So yeah, actually, Viper. Wait. That's a good point. Why don't we just do it in groups of 16? And then it's not a big deal. So 8-bit timestamp gets a clock, buff 1 through 15. Let's delete these for now. Yeah, that's actually the right way to do it. Because then we can just do something like that. And then we get 1, 2, 3, 4, yeah, basically. And then that solves the short-term problem of what's going on with this I really need to remap F2 to be rename instead of zoom. Okay, well, let's make this buffer low. I'm just calling these PIO 1, 2, 3. That's probably not the right designator. But I just want to keep track because I'm thinking these are going to be their own state machines. There. Oh, I totally forgot I did that. Thank you. Can we get back buff 31? Yeah, let's try to do that. All right, so let's just do this. Yeah, we can actually. Assuming I don't need any other signals. There we go. So then my only other question is, and maybe I will play around with this, is can we do something where I would really like if we could use an internal timer. So when I was doing the previous design, I never considered an internal counter because I knew I was going to have to put the counts on both data sets. So in the 2040 version, I was going to connect two boards together where one board took care of the clock and one board took care of the timer, but then they each did 16 bits. And then in software, I was going to just tie it all back together. However, now I'm thinking if we stay inside the chip, there's got to be a way that when a DMA occurs out of the PIOs, I should be able to grab one of the internal timer values. Or counter. I guess it'd be a counter. It's probably because it's actually probably PIO 1, state machine 1, 2, 3. But all I want to point out is just that I'm just highlighting how we're going to group them. It's not that critical. Yeah. So, because if we could do that and we could get back these 9 bits, that would be awesome. Okay. Item number next. Let's mess around with this probe input because I don't know, do I want to do this right now? I feel like I want to go ahead and do this now so that we can get it done. I know one thing we can do. We can delete these. We're not going to need those. Famous last words. Hey, and Blair, you think it's a typo? I agree. Run a counter in one state machine and make it read the relevant clock pin. Yeah, that's actually what I'm planning to do. I'm not sure when you said that, Christian. But does the PIO have a counter? But I think if you don't, you would still lose. Yeah, I guess that's the question. Does the PIO have a counter? I don't think it does. I could easily be wrong. Yeah, because if I think about it, it doesn't have a instruction for it. Yeah, basically, I think the only counter is the, wait. Yeah. Okay. Um, so 432-bit FIFO buffers, right? And they're all DMA-able. Yep. And then so we could fill one with a counter value. Yeah, I guess in theory, I think that's possible. I don't know how you wire that up so that it does that. But here's what I'm thinking is that is not a problem that I want to solve tonight because most of what I wanted to try to figure out is I've actually already solved the one thing I wanted to know, which was do we have enough pins to do a reasonable job this time. With the 2040, I was really hacking this to make it work. I mean, I should also take a moment and point out this really needs to be a this really should be a FPGA. This should not be in a microcontroller. The only real reason I want to do this is because I just want to see if I can, but I just want to point out the reality is it's very silly to do this even with the 2040 or the whatever. This would be almost no problem to do in an FPGA. So I'm only pointing that out because a lot of this is just a proof of concept. And so, yeah, anyway. I'm just trying to, at the moment, I'm just trying to organize these group signals to something that's more coherent for this design, which is why I'm only modifying the symbol in the schematic because I don't really care. I don't want this in the I don't want to change the library symbol. Ah. Really? 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 Hey, Jim. Good to see you. Good to see you again. Glad you came back. Yeah, I should also point out there is a less than zero chance I scrap the discrete design and just get something like a stamp from Solder Party, or I think I never know how to say his name. I think it's Arturo. So he makes basically so he made one for the 2040, and I think he's made one available for both of the new RP or the 2350s. But he basically makes a square stamp that has the microcontroller stuff on it, and then castellated pads around the edge, so you can just slap that onto a board. And so I haven't entirely decided that I want to go that direction, but I might actually scrap this and just go that direction. Regardless, I still need to figure out what GPIOs we need and how we're going to use them. So this is still useful even if I end up going that route. But yeah, that's why I'm not super focused on the rest of the circuit yet, because I'm not convinced I'm going to use it. All right. We're just going to... you can actually... Yeah, actually, FPGA, I mean, if you go back and look at like Agilent and Tech logic analyzers back in the early 2000s, like the vast majority after you got past the comparators, it was just a big ass FPGA. So the kind of thing that we're doing is just so much easier to handle in FPGA, but I don't know how to program them yet. So FIFO fill counter would have a DMA operation on the main system outside the PIO blocks. Yeah, see, that might not work so well. I mean, I'm not opposed to having the external counter. It just seems silly to have it. But where I'm sort of leaning at, well, I don't know. I'm not going to worry, like, okay, I got sidetracked. I'm not going to worry about the counter thing at the moment because I don't have any use for those I/O pins anyway. So at worst, all I'll do is delete everything later. Or I might leave the stuff and just do solder jumpers so that I could disconnect it if I want. But yeah, because I think we're not gonna submit a PCB tonight. So an experiment could be, could we get the DMA buffer stuff with counter to work with with a Pico? You know, if we could capture 4 bits of data and 4 bits of counter, and figure out how to make that work, then you know it'd be a good experiment. So. Okay, let's go ahead and fill in the rest of this design real quick. Even though I think I said I wasn't going to, I changed my mind. I'm going to. Let's get another instance going so that we can see what's going on. Oh, Viper, I see what you're saying. So. Okay. Now I got it. You said bidirectional. Now I got it. So you're saying we have the counter running, and we just FIFO the counter value into the PIO, and then whenever we DMA the data back out, we'll get whatever the current counter value is, right? So basically, we have the counter running, and on a regular basis, we FIFO that into one PIO, and then when we DMA all 3 PIOs out, we'll just get whatever value comes with it. That would probably work. That could work, and I'm pretty sure we can do that without using up any I/O pins, because it would just make use of the FIFO buffer that's already there. You don't have to wire the buffer up to a pin. So we'll still use up 3 GPIO or three state machines, I think. I always forget how to separate PIO module and state machine, but we need 3 blocks. Yeah, I like that idea. That could work. Okay. All right, so let's see what this this is a reference design that Solder Party put together. I don't think this was the official. Maybe it is the official. I got it from him. So they're still doing 12 megahertz crystal. That's good. I'm doing 12 megahertz crystal already. So I'm just going to come over here and I'm just going to take whatever crystal I have, and we're going to put it. Oh, come on, guys, really? Why isn't your symbol better than this? Where did I have the run pin on my symbol? Yeah, that's what I thought. So let's move this stuff. How did I do this before? So we had run, USB, QSpy, crystal. Okay. So let's come in here and do edit symbol. So I'll leave the regulator stuff up here, but let's move all of this down. Okay, and then I want run at the top or near the top. And I want USB under that, so we'll just put these over here for the moment. I'll grab all of these, we're gonna bring all these down, 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 down. Okay. And then I'll put USB roughly there. That's what I should do. That looks much better. Okay, so the USBs are fine. And then the QSpies are okay. We're gonna have to move some of these around a little bit, but whatever. For the moment, it probably makes more sense to include a flash in case I can't get a hold of the chip that has flash, right? That just sounds like a good idea to me. All right, so let's save this. And I'm going to come back over here. And we're going to grab this. I'm going to move this over to here. So I can go 1, 2 down. Move 1, 2. Yeah, that looks good. Okay, and then I'm going to come over here and let's take all of this, including that. We're going to move that over to here. Oh, come on. All right, so we got to go move 1 down. Save. Uh-oh. Move 1 up. Save. That's not good. Are you not on the grid? Oh, this part is broke. I don't want to do this, but I'm going to. Oh. Okay. Never mind. So we'll change this symbol now. Move all this stuff. Actually, I think all I got to do is, if I do this, does that get that back onto a grid? I think what's going on is I must have created this original, or I must have created the schematic on a 50 mil grid instead of the 100 mil grid, and now I'm stuck to the 100 mil grid, so I'm having to move everything back around. I think that's what's happening. All right, and then let's go ahead and grab this stuff, and we'll just move this as is right over to here. Really? Really? Okay. All right. And then let's add a ground. And then what did I do for run? Did I just have that? I did this, and then I have the push buttons. Yeah, so this is actually working out pretty easily to, or pretty well to quote unquote upgrade. We do need to add a, we need some RAM. The whole reason I want to add more RAM is so we can get more samples, you know. Actually, Should be obvious, but just in case it's not. All right. Okay. So now if I go back to the minimal design, I want to see what they're doing with the power supplies. So how did anyone else catch how many ground pins there are? Oh, I just lost my contacts. Both of them. That was a first. So how many ground pins does the 2350 have? The number might shock you. If I did this right, I can just do that. And what do they have for parts? Yeah, we're going to have to change those. I am not doing 0402s. Or maybe I should probably get this assembled. I might do assembly on this one. Just because I don't want to deal with it. What inductor I wonder they're using? Okay. Okay. Yeah, nice. All right, you know what? I'm just going to copy it full right now. All right. Ah. Whoops. My bad. I hit the wrong button. Sorry, Team K. That was so not on purpose. This worked. Okay. Well, what do you know? Now we have a functional circuit. Yeah, right. You picked the wrong second. That's all I can say. Okay. I'm going to take this out for now. RP2350 I. All right, so that's going to come over here somewhere. All right, so let's see what ERC thinks about what we've done so far. What is off the grid? Of course. Really? All because I was a rebel and used the wrong grid size. What was I ever thinking? No. Come on. All right, let's try that again. G, I think. We'll put stuff back on the grid. Oh my God, this is such a mess. Why did I do this wrong in the first place? That's killing me. Hey, Christian. Welcome back. Welcome again tonight. Disable ERC, it makes the picture look prettier. That's, you know, that is a valid point. The picture would be a lot prettier if you didn't run ERC. So by the way, speaking of ERC, we'll have a new add-ons video on probably Monday, maybe Tuesday. It's done. I still have to make the thumbnail and do all the social media stuff for it. But it is actually, speaking of boards, it is this board, which is, for those that remember, years ago, this was a stream project, and so I now have professionally assembled versions of this wing, and all the sensors on it are working. Well, except for the microphone, and that's only because I wrote all the code in CircuitPython, and I'm using an ESP32, which supports PDM microphones. The ESP32 supports PDM microphones. However, CircuitPython does not. So anyway, the reason I thought of that is because in the video, I make a comment about how I just changed my grid and now it's behaving. I make a comment how I finally learned how to use ERC, because back when we did that Bulb Sense project, that was in 2020, and back then I almost never ran ERC. Because I was like, well, it just complains about things that I already know about, so who cares? And then, I don't know, I think it was with the Mega 2 project, I realized I had to use ERC because there were just so many mistakes that it was catching. Come on. You're gonna have to write so much code. Actually, this version is going to be, I think this is actually going to make the code so much easier. The only thing I'm not convinced that I'm going to like is I don't know how to make a trigger sequencer. Which again, in an FPGA, it would just be part of the acquisition path, and so it would actually be relatively easy. But I'm actually thinking what I may end up doing is use one core to run the logic analyzer and then use the second core to run through the RAM and try to find patterns in the RAM to identify a trigger point, which isn't the ideal way to do it, but I think it's a possibility. And what I mean by sequence or a trigger sequencer, so like, again, if you've only ever used a timing analyzer that's like a USB based one, usually your trigger is limited to a pattern or an edge or a combination of edges and pattern. What's really fun when you have a state mode logic analyzer is because each state is a valid state of the bus. You can do things like you could actually set up a sequence where, say like on the Apple II, that you only capture data for 10 clocks after an access to one of the soft switches, so that you can see what's going on after that, but you don't care about anything else. Or you're looking for, if these 3 switches get hit, then trigger. And so it's difficult to do that on a timing analyzer because the signals aren't always well qualified. And so, yeah, anyway, that's just one of the things I don't know if we're going to be able to do that in the 2350, but I'm hoping to maybe prototype that capability, and then eventually I think I am going to make this an FPGA project, but I'm not there yet. Okay, I don't understand why this is. This is painful. How do you specify or determine the pattern? I mean, that's going to be up to you and what you're probing or how you're measuring. The most common thing would be is like if you're looking for an address, so that's what your pattern is. If you want a sequence, you might say, I want this address followed by this address followed by this address. Or if you get this address, reset and start looking again. But yeah, I mean, the pattern itself is, you define that. You just say, I want these bits to be some value, which is usually the limit of most logic analyzers today. Like even on the analog discovery or the digital discovery, its logic analyzer, the most advanced it can do on a parallel bus is detect a pattern, which is still useful and it's still helpful, but I always want it like, another way that it's really helpful too is if you're trying to figure out how often is an address getting hit, you could do, so then there was qualified storage as an option too, where you would only store values that hit certain patterns or after a certain sequence of patterns. And so then you could let the analyzer run for a couple of minutes and you would be able to tell how often is a certain event occurring just because that's all that's in its memory buffer. You know, you couldn't really debug a whole lot with that, but that's not the point of that measurement. I don't understand why these are still complaining. Do that in computer end, compare branch, yeah. Yeah, I mean, so the thing to remember is, as a state mode logic analyzer, the samples are only going to come in at most a couple of megahertz. Now, I mean, obviously it depends on what you're probing, but I'm targeting like 10 megahertz and slower. So it's totally plausible that you do a post trigger analysis that always takes a little bit longer than what's getting streamed into acquisition memory, because the second core should still be able to go through a bunch of instructions before the next sample comes in. Or even if it does, it's only ever going to be a couple of samples behind. And so it's probably still going to be reasonable. Now, if you were trying to stream in samples at 100 megahertz and then do what I'm talking about, that wouldn't happen. But at least especially for the 2350 design, my target is vintage computers. So I'm talking things running megahertz, and so we're not going to be stressing anything out in terms of the 2350 specs. Okay, is it because I changed to a 50 mil grid? But and I think I don't mean to keep repeating this, but it's just I think most people think in terms of a timing analyzer, and when you have a true state analyzer, it's a completely different way of looking at things. Now, what I will back up and say is I worked for Agilent. Agilent's analyzers were fundamentally state machines, meaning the entire acquisition chain ran off of the duck clock. Tektronix had state mode in their logic analyzers, but they used an asynchronous front end and then reconstructed state on the back end. And so even though for like 15 years, I drank the Agilent Kool-Aid on this is the way a logic analyzer should work, I actually do see value on doing a high-speed timing analyzer and then reconstruct state after. But I feel like that is absolutely a FPGA project. Like, I don't think it'd be worth trying to implement that in a microcontroller. So. But yeah, it's just where I'm coming from on this is when we were doing the Mega 2 stuff, as much as I love the digital discovery, it was just a pain because it's a timing analyzer. And so, and on a bus that's really glitchy, it's really tough to get good samples. Okay, oh my God, that's not, oh my God. It's not complaining about being off grid. It's complaining that the flag was modified, or the symbol is modified. This whole time I've been trying. This whole time. And it's probably because this was originally done in 7 or maybe even 6, and now we're in 8. I never looked at the actual DRC. I just thought it was off grid. Is this planned to be time-based synced? Yes. Yep, it is. So basically, just to point out, so here's the general idea. Is we're going to have 3 blocks of signals, 2 16-bit data buses, each with a copy of the clock, and then an 8-bit timestamp with a clock. So the timestamp gets generated from a couple of counters. And so this will basically be how we can tell how long it's been between transitions. It also, in this design, it's less critical. In the old design where I had 2 different boards, I needed the timestamp counters so that you could realign the acquisition buffers. But that's not going to be an issue here. Now, the trick with a state mode analyzer is that you have to change the position of the clock so that you're sampling in the middle of the bus's data valid window and not when the clock transitions. And so I have this circuit that we still need to test that actually takes in the clock somehow. We got to clean this up. So basically this circuit, because of this part right here, it can take in a clock and it can delay it by whatever time you want. And so we can actually use this to delay the clock so that we kind of time shift it so that we get valid samples when the clock transitions. Which, the way that Agilent logic analyzers did it, each data bit actually had a digital delay that you could dial in. And so then it would basically, they would actually delay each of the data lines. Without an FPGA, that's cost prohibitive. So I'm just going to move the clock. And that was actually when I did the video on, so I was trying to do a video on this state mode analyzer, and I ran into so many problems getting the boards to work that I just turned it into a how-to guide on troubleshooting RP2040 boards. I had hoped in that video I was going to at least get the delay circuit working, because I really want to see if this idea is going to work or not. I mean, obviously it's going to work. It's just a matter of how much time will it take. All right, does that clean up a lot of that? Buff 0 to 15 plus clock into each plus the timestamp into each PIO. Yeah, I'll think about that. If we go with your idea where we just, yeah, that might actually work. At the moment, I'm not gonna. If we end up using an internal counter, which I think our idea will work, then I will do what you just said. Is I'll probably use whatever bits are left over to be the timestamp counter, and then that way, at least as an optional way to do it. I don't know. Maybe it's not necessary. We'll see. I'll keep that one on the. I don't think there's enough signals outside. There's not enough I/O pins to do it if we use an external counter, though. Hey, Silent, good to see you. Welcome in tonight. Yeah. The actually what's going to limit the sample rate, which is actually not the right word. I'm trying to remember what we called it. I think it might be acquisition rate, because we're not not controlling the sample rate. Since the target controls the sample rate. But what ultimately limits the acquisition rate is the resolution of your timestamps. So, like in an ideal world, and if we use if we use a PIO, like we were talking about earlier, if we can get a 32-bit timestamp, then yeah, we can go really, really fast. Like that. Yeah. Is there a faster way to fix this other than go back in time? Let me make sure this is complaining about what I think it's complaining about this time. Yeah, it's off grid. Okay. This is not fun. Yeah, audio. Yeah, there's something wrong with the audio tonight. Sorry. I should probably pin that. Come on. what's this one? Symbol or pin is off grid, except there's nothing there. Wonder if it's a hidden pin. Yep, that's what it's complaining about, a hidden pin. And now it's going to say, this symbol's been changed. Although that one I might actually turn off because I don't really care. All right, those are clean. That's clean. Where are we at? Where else do you want to complain? I just copied this. How can that be off the grid? You're off the grid, jerk. What's this complaining about? Why is this red? I can't select it. Input pin not driven. Okay, I'm not going to worry about those for the moment, because we can fix those later. That does need to be addressed, but I'm not concerned about that at the moment, since we just copied the power circuit from the other design. I'm not at all surprised. There could be a problem. Setup qualification, the PIO, use DMA to drive the state machine. It's funny. I always think, man, I really understand how the circuit works. And then I talk to Geek, and it's like, nope, I don't. I do not understand the PIO as well as I thought I did. Which is another reason I wanted to do this project, is it just seems like such a fun way to learn about it. All right. What's this one complaining about? And then let's bring this down here. What if I highlight both of these? Wait, other one. If I go like this and then say G. Yeah, that's not a good idea. What about this? Geometry. Okay. Delete. Delete. G. G. No re. Run. Okay. Well, this is such a... Come on, really? Oh, it's been modified. Okay. Update symbol, all matching, update, close, run. Oh my God. So I can't just do like G. Like with that, does that work? Does that trick it? No. What if I do this, and then this, and then this, and then this, and then this. Run, run, run. I really, 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 really wish this window was dockable. Like, I would like to just have it right on the side so that I don't have to keep opening and closing it or moving it. Now someone's going to be like, oh, it is dockable. You know that, right? I'm just kidding. Python script to fix it. Yeah, actually, I wonder now, is there maybe a plugin or a Python like utility that somebody wrote to, I don't know, I don't know how you make some of the decisions on how to fix like this stuff. Come on. Nope. I think I double clicked. Can't double click. That's not allowed. That's not allowed around here. This has been modified. It has not been modified. Calm down. Oh my God. I just made a mess. All right. I will get rid of these stupid stupids. So stupids. That's stupid too. That's another stupid. There's more stupid. That's also stupid. That's stupid. That's stupid. I hate stupid. Does this even matter? Am I wasting my time? Because are they actually, they're connected. They're just off grid, right? Okay. Okay. Look, I fixed it. Ah. The age of AI, all we need is fix ERC button. Yeah. I mean, you know, people want to talk about using AI to do PCB layout. I don't care about that. I would love for AI to be able to look at this and be like, oh, this is a whole bunch of repetitive stuff that I could easily change without you thinking about it. That would be fine with me. You know, like, why not? All right, what else we got? Yep, this one. I am doing these symbol updates just because I'm out of reasons. Why wouldn't I? Wait, it was not found in library. Okay, well this one I don't care about that one. Was not found in symbol library. Really? Yeah, that's the right one. Huh. I don't know what it's complaining about. Oh, it's saying the symbol itself wasn't found in the library. So if we come in here and we look for USB, come on, USB-C receptacle, D minus, that's power only. The 14 pin version, the 16 version. There we go. All right, so that's not connected, pin not connected. Okay, see, that's a real one. Well, that's actually an error, so there's that too. What? So I think the problem with that is it doesn't work in certain situations. So like, of course, no, I can't. So like, it would be ideal is if I can just highlight everything, say right click, align to grid. Yeah, that'd be great if it worked like that, you know, where you could like highlight the stuff and then say right click and align to grid. It'd be really, really nice if it worked that way. I just wish it worked exactly like this, where I just highlight everything and I say align item to grid, and then I move it, you know, put it somewhere nicer. Yeah, it would be. That'd be really great if it did that. Yeah, I knew there was a trick. Now, I think we're going to end up with some things over here that's not right. What happened? Okay, I know what's going on. There. And then, I'm not sure why these got messed up, but we'll take 1 second and fix these. Okay, so align to grid was what I was trying to remember, so thank you. Obviously, what I remember though is it's not always perfect, but clearly I just did it like 4 times in a row where it was a hell of a lot faster than what I was doing. So maybe it's not perfect, but at least it's better than pixel pushing for the entire night. Like, having to clean up a little bit is easier than cleaning up a lot. I'm pretty sure I did this with version 7 because it was October last year, and there's no reason I would have been using 6 that late in the year. If it was before June, it's possible because I usually wait about until May or June before I finally switch over. And it's not even and it's more of just because like a lot of times people are like, well, this used to work and now it doesn't. And I'm always curious to understand what changed. And so I don't always pay attention to which version I load up to work on something. Okay, so that's nice. I'm gonna snapshot this. So autosave files should never be nothing with a lock. And the sim table we don't need. All right, let's just say I'm not looking for a strong commitment there. Okay. I guess I was actually doing warnings, not errors. Whatever. So input pin not driven by anything. Wait, which one is this complaining about? It's the 1.1 volt. So that should be... That's coming from over here somewhere. Because isn't... I thought the chip had its own internal regulator. Like it has the, I thought it had a LDO for 1 volt, and then I thought it had a switch mode for 3.3. Do I have that back? Boot, power supplies. Let's just go to the power section. So IO VDD, let's see, power EMD, set for threshold, safe, but will result, mate, blah, blah, blah. QSPI IO is for the QSPI interface. Okay, oh, QSPI IO, I wasn't paying attention. So DVDD is powered. It should be a nominal 1.1 volt. A dedicated on-chip voltage regulator allows it to be generated from... Huh. So VREG-N gets you 2.7 to reduce the number of supplies, same 4.7. That's for the core voltage, right? Yeah. I'm confused. I have a confuse. So there is an on-chip regulator for DVDD, which comes from the input supply. Yeah, so those are actually... Okay, so that must be why KiCad's confused, because I'll bet these aren't defined as power outputs. Yeah. Okay. Well, because, yeah, so now I remember what they did. It used, the 2040 has a linear regulator for 1.1 volt. But the 2350 has a switch mode regulator for the 1.1 volt. And so these are actually 1.1 volt supplies. I think. Anyway, what's this complaining about? Not connected to anything. Well, I think that is not true. I think they're supposed to be connected over here. Like plus and negative. All right. You're supposed to grab it yourself? Really? Close the... Does this have... This is the hardware design document. I just wonder if it actually talks about... Talks about decoupling capacitors. Great. Huh. So the regulator has 2 pins, 3.3 volt in and 1.1 volt supply. This time the regulator has 5 pins. Oh, the 2040. So blah, blah, blah. As the name suggests, the help of an inductor can produce a DC voltage. Just step down from the input. Monitors the output, adjust the on-off, la, 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 large current, yeah. Okay. Okay, so this is where the power flag goes then. DN power flag. Because that's actually where it's being generated. Okay. Hey, Commodore. YouTube is still there. And I'll actually have an Atoms video coming pretty soon. All right, thanks, Viper. I missed that. I mean, technically, well, I don't know. I guess technically you could probably do some kind of divider here on the feedback to change the output voltage. But I think the reality is you could just not use their switch regulator and supply your own core voltage. So, all right, so these things aren't connected to anything. That's fine. I mean, it's not fine, but for the moment, I don't care. Output and output are both connected. That's because this symbol is wrong. This symbol is supposed to be all passives because it is a connector. Yeah. Let's go passive, passive, passive. I'm leaving the unconnecteds because why not? Okay. And then I can right click and update symbol. Then we can run that again. All right, so these are not connected to anything. I'm not worried about that because I know they're not connected to anything, so that's like not a major concern. And then let's see, so this is getting driven by, okay, so that should just have a flag here. Because it's actually getting driven from this signal here. And then they're looks like they're doing an RC filter into there. I think that's what's going on. 33 ohms. Come on. Okay, cool. That's actually, because basically to get these fixed, we have to add some more buffers, which I'm still debating if I want. But I probably want, just because it'll protect the the microcontroller. But then again, the microcontroller costs $1, and these buffers are like 70 cents each. Yeah, like like $1 each by themselves. 50 cents if I get them in 1,000. Okay. Well, what a deal. I don't know. I don't know about that. That seems like that's not the direction I want that to go. We'll need microcontrollers to protect our buffers. Oh yeah, I forgot about the properties panel. I always forget about that. See, I stopped using the properties panel in version 8 because there was a significant bug with it. And after the 3rd or 4th minor release, it hadn't been fixed. I actually don't think it's been fixed yet. I wonder if I can remember how to do it. Let's save. So what was it? It's if you copy and paste a part, and then, oh, that's not the properties panel. And then you come in and you change something like its value to 100U. And then if you copy and paste very quickly, nope, that didn't work. What if I change this to 1U? I think what it is I do copy paste right away. I'll have to go back and look at the bug, but there was a bug similar to this similar to this behavior where if you copied and pasted, maybe, wait, let's try one other thing. If you do this, I come in here and I say, I want this to be 100U, and then I copy and paste, but then come back and edit this one. No. Yeah, I can't remember. There was something about editing properties which would reset anything that you changed with the property panel. And I don't remember the sequence now. I mean, maybe it's fixed, but it was a sequence that it kept tripping me up, and so I just stopped using the panel altogether. So anyway, but you are right. It would be a lot faster than what I did. Okay, I want to do one more thing. I want to push this to PCB and see what it's going to look like so far. So I pressed F8, now we wait. 7 errors, cannot use footprint for this. Well, the footprint I wanted, it didn't bring. Okay, so let's go figure it out. Oh, okay. Well, since I've got PCB open, let's go to Manage Footprint Libraries. And for this project, no, change my mind. For the global, we're going to go to, shoot, I got to go find it. Okay. All right. So now we'll do tools, update PCB schematic. And now we get our totally massive QFN. Yep, that's going to go right there. Oh. Yeah, I'm going to get rid of these expansion connectors. We don't need those anymore. Now the question is going to be, how do I want to lay this out? Because we're going to have two of these connectors side by side. Maybe I can just make this like one long card. Yeah. Let's go ahead and get rid of these. We're not going to need them. That's not what I want. This one. So I want to get rid of these extension connectors. We don't need them anymore. That's probably all I can get rid of at the moment. But boy, that's going to clean up a ton of stuff, not having to route those signals all over the place. I mean, at this point, I might as well just rip this whole thing apart because none of this is staying in place. I'm going to save because I want to do a, how do you rip up all of the tracks? I want to do all tracks. No. Tools, clean up tracks and vias. That's not really what I wanted. I guess the easiest way to do this is just say select tracks and vias. And then do this and delete. I thought there was like a menu somewhere that you could, isn't there, is there like, oh, global deletions, that's what it was. And here you could say delete tracks and vias. Okay. Turn off the fab layers too. Oh, that's so much easier. Yep. We have a lot of work to do. We lose an LED? Yeah. Huh. I wonder if I deleted it and didn't realize it. Whoops. Yeah, that was the fun part. So, okay. Well, here's where I'm at. We're gonna wrap up. I actually got a lot farther in terms of what this is going to look like than I was planning. The biggest thing is I wanted to get an idea of whether we were going to have enough I/O pins to do what I wanted. And at the moment, I feel like we have enough I/O pins to do what I want, which is pretty exciting, actually. You know, the only other thing... we're just out of I/O. Well, we might still be able to get rid of this clock. So I'm gonna try to like work out an experiment. Maybe I'll actually, is this gonna show up or is this gonna be keyed out? So I've got a Pico 2. So I've got a 53 or 2350, even though it's an A, but I think I could rig up a test to see if we can make our counter into the PIO and then DMA it back out work. Because if so, then I can get rid of this external counter, which gives me a whole bunch of pin options, right? So that is a TBD. Cool. All right. Stay tuned on, what do you call it? On YouTube, like I said, Monday, maybe Tuesday, I have a new video coming out. As I always like to say, I am legally required to have a Discord since I do live streams. So go check those out. Yeah. This is fun. I'm pretty excited about this chip. I'm not super, I don't feel a lot of pressure to get this board done since the chips aren't all that readily available yet. So I feel like we've got plenty of time to kind of work through this, and that's why I kind of like the idea of doing some experiments. So maybe if I can get at least the base code working, maybe next week we'll work on trying to talk to the what do you call it? It's not what I wanted. Anyway, yeah, it does get keyed. So I want to do a couple of code things just to see if we can get that to work. And then I guess the other thing we could try before we get too far in the PCB design is on the original board is to try working with that clock delay circuit, because it shouldn't really rely on anything. So yeah, we might play around with that. So all right, thanks for hanging out. It was fun. I shared the links. Remember, try to find time to do something you enjoy, and if you do, share it with other people. Until I see you next time, have a good one. Talk to you later. Bye. This button.